Hey guys, welcome to Pre-Calc lesson 2.5 on rational inequalities. What we're going to do today is we are going to solve rational inequalities both algebraically and graphically. First thing I'm going to do is go through the algebraic steps. There's a few of them. Normally I'm not a huge fan of memorizing steps, but these are pretty critical to solving these rational inequalities. First thing you're going to do is get 0 on one side. So if there's any terms on the other side of the inequality, you want to subtract them over, add them over, whatever it takes to get them over on the other side. Then what you need to do is combine terms into a single fraction. And you can do that by getting common denominators. Okay, so once you've done that, you've got a single fraction. We're going to set the numerator equal to 0. And what that's going to do is that's going to get you your roots. After that, you're going to set the denominator equal to 0. And that's going to get your restrictions. Restrictions on your domain, so places where the function does not exist. And lastly, you're going to create a plus minus line. Using the roots and restrictions. Actually, there's one more I forgot. Then we're going to interpret the inequality. So does the inequality want greater than 0, so want the positive pieces, or does it want less than 0, want the negative pieces? All right, let's take a look at an example here. So first thing from up above, I need to set one side to 0. I'm going to subtract 2. That gives me 4 over x minus 2 is less than or equal to 0. So I need to combine like terms. All right, well, that means I need to get this to be a fraction that has an x in the denominator. So to do that, I'm going to multiply by x over x, which will give me 2x over x. So 4 over x minus 2x over x is less than or equal to 0. My numerator is 4 minus 2x. My denominator is just x. And all of that's less than or equal to 0. So now I've got my single fraction. And this is the fraction that we're going to use for the rest of the problem. So I'm not going to go back to anything up above. Okay, so now what do we do next? We set the numerator equal to 0 to find the roots. Roots will be numerator equal to 0. All right, so that's going to be 4 minus 2x equals 0. Subtract 4, negative 2x equals negative 4. Divide by negative 2, x equals 2. So we have one root. Next, I'm going to find my restrictions. Those are found by setting the denominator equal to 0. Well, that's pretty easy. It's just x, so that's going to be x equals 0. So there's only going to be two numbers on my number line. Make sure you put them in numeric order. So I've got 0 and 2. Now, there's not going to be any set pattern for these, kind of like there is for a quadratic. What we need to do next is we need to look at what I've highlighted right here, and you have to determine whether it's positive or negative here. Whether it's positive or negative here, and same thing, positive or negative there. So I need to pick numbers in this interval, something less than 0. I need to pick something between 0 and 2. I need to pick something that's greater than 2. All right, well, let me choose, let's say, negative 10 here. Let me pick 1 here, and let me pick positive 10 there. Notice I can't pick 0 because 0 is one of my critical values. Now, here's what I like to do. It's going to get messy because obviously we have these fractions. Remember, you only need to figure out, is it positive or is it negative? And since it's a fraction, what we're going to do is we're going to figure out if the numerator is positive or negative, if the denominator is positive or negative, and then just remember, If the signs are the same and you divide, it's positive. Signs are different and you divide, it's negative. So I'm going to go through and plug in a negative 10. I'm going to plug in a negative 10 right here. You just got to be careful. 4 minus 2 times negative 10. That's going to give me a positive 20. So the numerator of my fraction is going to be positive. And then if I plug a negative 10 in the denominator, well, that's just negative 10. So the bottom of my fraction is going to be negative. So I have a positive divided by negative. So overall, that's going to be negative. Next, I'm going to plug in a 1 here and here. Well, on the top, if I plug in a 1, 4 minus 2 is positive. So the top of my fraction is going to be positive. And if I plug in a 1 down here, well, that's just positive, right? So the bottom of my fraction is positive. A positive divided by a positive gives me a positive. So that piece is going to be positive. Now let's plug in my 10 here and here. 4 minus 2 times 10, that's going to be negative. 10 down here is going to be positive. So I end up with a negative over a positive, which gives me a negative. So now I know the pieces of my number line. This is negative, that's negative. This piece is positive. Well, which one do we want? It depends on the original inequality. So I'm going to come back here and notice this says less than or equal to 0. So that means negative. I want the negative pieces. Let me use a different color. This tells me I want the negative. So, and notice this here is or equal to. And this is what's important. This is a very tricky question. The restrictions, no matter what the inequality, always represents an open circle because it can't be that. It's not in the domain. So at 0, that has to be an open circle. Even if this says or equal to, this is going to be open because it's a restriction. It's not in the domain. Now the other piece, the root, it is going to equal that. So this is going to be a closed circle. This is why these are so tricky. And I'm going to shade the negative pieces. So the solution to this inequality represents this number line right here. I would say x is less than 0 or x is greater than or equal to 2. All right, let's try another one. Okay, so again, I need to subtract 3x to the other side. This is going to give me 3 over x minus 3x is greater than 0. Now we got to combine these. So that denominator is an x. I need this denominator to be an x. So I'm multiplying by x over x. 3x times x is going to give me 3x squared. All right, so let's write that down. I've got 3 over x minus 3x squared over x is greater than 0. 3 minus 3x squared all over x is greater than 0. Now I've got my single fraction and my inequality. This is what I'm going to use for the rest of the problem. All right, set the numerator equal to 0. That's going to find your roots. Just a reminder here how we do it. So I've got 3 minus 3x squared equals 0. I'm going to factor out a 3, or you can just divide off both sides. It's not really going to matter. Let's do that because it's not part of your root. 1 minus x squared equals 0. Factor that 1 plus x. 1 minus x equals 0. So I get x equals plus or minus 1. I've got 2 roots. So now my restrictions, that's going to be denominator equal to 0. So that's just going to be x equals 0. Now this one's going to be a little more challenging because notice your number line. I've got 3 values now, -1, +1, and 0. So let's set that up on my number line. You have to put those in numeric order. So -1 is going to be the smallest. Then I've got 0, and I've got +1. So now, once again, I need to figure out, is this positive or negative? Is that positive or negative? Is that positive or negative? Is that positive or negative? I'm going to be using this. I've got to make up numbers in this interval, in this interval, in this interval, and in that interval. All right, not super easy. I'm going to pick -10 here. I'm going to pick +10 way over here. But notice, between -1 and 0, you don't have a lot of choices. I'm going to pick -1/2. and I'm going to pick positive 1/2. You might be thinking, oh, this is going to be a major pain. But remember, I don't need the exact value. I just need positive or negative. So first, let's take negative 10 and plug it in here and here to determine my fraction. All right, so here's my fraction. If I plug a negative 10 in here, you're going to square it. So that's going to become positive 100. 3 minus 300 is negative. So the top of my fraction is going to be negative. If you plug a negative 10 in here, the bottom of your fraction is negative. Well, if I have a fraction where the top is negative and the bottom is negative, overall that's going to give me a positive. Let's go with negative 1/2. Again, that can be daunting, but it's not as bad as it seems. So I know right away, if I plug in a negative 1/2 down the bottom, that's just going to be negative. So the denominator is negative. Well, let's see what's going to happen if I plug a negative 1/2 up here. Negative 1/2 squared is positive 1/4. So I've got 3 minus 3/4. Well, that's just going to be positive. And overall, this fraction then would be negative because I have a positive divided by negative, so that's going to give me a negative. Now, if I plug in a positive 1/2, positive 1/2 is going to give me the same exact numerator, isn't it? Because if you think about it, I put 1/2 up here, I square it, it's still 1/4. 3 minus 3/4 is still going to be positive. But what changes here, when you put this down at the bottom, well, that's going to be a positive 1/2 now instead of a negative. So my bottom is going to be positive. Now this fraction is a positive divided by positive, which is positive. And the last one as well should be very similar to the first one we did. If I put a 10 in the bottom, that's positive. So the bottom of this fraction is positive. And if I plug a 10 up here, it's going to be 3 minus 300 again, which is negative. So overall, this fraction is going to be negative. It's a lot of work. You can't just make up the signs. They don't always alternate. I know they probably will for these examples, but they don't always in every function. So we have to go through this process for every one of these values between my critical points. So now, all I have to do is interpret the inequality. That's the hard part. This should be the easy part. This says greater than 0. Now, this is also easier because when it says greater than 0, all circles will be open. So I want the positive pieces in all open circles. Remember, your restrictions, no matter what, even if this said or equal to, restrictions are always open, but I don't even have to worry about it on this one. All right, so open circles. And I want the positive pieces. So I want this piece here. And I want this piece here. So now, how am I going to express this solution? I'm going to say x is less than negative 1, or 0 is less than x is less than 1. Those two intervals represent my solution. Okay, let's take a look at two more. Translating two-dimensional graphs to one-dimensional plus-minus number lines. So we're going to do this algebraically first, and then I want you guys to check it graphically. All right, and graphically might actually be a little bit more confusing because you can see some pretty weird graphs. But anyway, first thing I'm going to do is subtract the 2x over. It gives me 8 over x minus 2x is less than or equal to 0. Common denominator is going to be x, so I'll multiply by x over x. So the top's going to become 2x squared. And then you just combine those numerators. 8 minus 2x squared all over x is less than or equal to 0. Okay, next we can get our roots. And that's going to be numerator equal to 0. So 8 minus 2x squared equals 0. Let's divide everything by 2. 4 minus x squared equals 0. 2 plus x, 2 minus x. If you're solving it this way, no matter what, you can get plus or minus 2 for your roots. My restrictions, denominator equal to 0. Well, again, that's just x equals 0. Good. So now I need to do a number line. My number line is going to have 3 values on it. It's going to have negative 2. It's going to have 0. It's going to have positive 2. Next, I have to pick numbers in these intervals to plug into this. I didn't highlight it this time, but Hopefully you get the idea. We're just using this from here on out. Ignore the stuff up above. All right, let's see. Kind of boring, so I like to pick the same stuff. -10, and here I'll pick -1. Between those, I can pick 1, and after that, I'll pick +10. So for all of these, I'm just determining, is the fraction, that's a fraction bar too, that's not a negative. I hope you guys figured that out. That's a fraction bar, represents this right here. So if I plug in -10 in the denominator, it's going to be negative. All right, so my denominator is negative. If I plug a -10 up here, that's going to give me +100. 8 minus 2 times 100, that's going to be negative. So I have a negative divided by negative. Overall, it's positive. Okay, plug a -1 in the bottom. The denominator is going to be negative. Plug a -1 up here. That's going to be 8 minus 2. That's going to be positive. So now I have a positive divided by a negative. Guess what? That's negative. The only difference with this one, with a positive one, is your denominator is now going to be positive, right? Top is still going to be positive. So this fraction will be a positive over positive, which is positive. And same thing here. See, it goes quickly once you kind of recognize the pattern. The bottom's going to be positive. Top's going to be negative. All right, so it's going to be a negative divided by positive, and that's going to give me a negative. Okay, now what? Now we interpret. Less than 0 would be the negatives. Closed circles, except at that, because it's a restriction. So your 0 is an open circle. But the other ones have to be closed because it's or equal to. So basically, this or equal to represents the roots right here. So these have to be closed. Restriction is always open. So roots will be closed. And we said we want the negative because it says less than 0. So I want this piece here. That part of the number line is negative. And I want that piece there. That's also negative. How do you write that inequality? -2 is less than or equal to x is less than 0, or x is greater than or equal to 2. Really have to keep track of those or equal to's or not. It's going to be a little bit confusing. So now, what I want you to do next, unfortunately I can't show you this on my calculator, so hopefully you can get a good picture of it, but I want you to put this right here into y1. All right, put this into y1 exactly the way it is, and then graph. I'm going to sketch what I see on my calculator right now. All right, it's kind of a strange graph, looks like this. So I've got -2 and +2. And this right here, let me use a different color, is an asymptote. The graph kind of goes like this. And this. All right, so that's great. What does that mean? Call that y1. Well, what do we want to know? We want to know where this graph is less than or equal to 0. So graphically, when you see less than 0, that means below the x-axis. So what pieces of this graph are below the x-axis? Well, this piece here and this piece here. All right. Now, I should also say below or on the x-axis because, notice that, or equal to. So basically what that's going to do is that's going to give me a closed circle here and going this way. So that's one piece, a closed circle here going that way. Well, visually now, I think you can see why one of the circles is open, because my asymptote right here, this piece will never get to 0. It keeps going down and getting closer and closer, but it'll never touch because that's an asymptote. So that's why this piece is represented by that interval right there, -2 to 0, but it never gets to 0. That's why that's open. And then this piece right here is greater than or equal to 2. All right, last one. Oh, 2 more. If you got the hang of it, you can probably skip these, but just in case you want some extra practice, I'm going to go through both of these, okay? All right, so first thing I'm going to do, subtract a 3 over. That's going to give me x over x plus 2 minus 3 is greater than or equal to 0. This one's actually a little bit more challenging to combine because I need to get a denominator of an x plus 2. So I'm actually going to write that out. I'm going to multiply by x plus 2 over x plus 2. What does that give me? This fraction is going to be x over x plus 2 minus 3x plus 6 over x plus 2. And all of that's greater than or equal to 0. Now, here's where we have to be very careful, all right? This is going to give us a little bit of grief. We have to distribute this to both of these terms. I just think that's the easiest thing to do. So what I want to do is I'm going to change this to plus, negate, negate. All right, I'll do that with a different color. Change that to plus, negate that, negate that. Now I can combine my like terms. So I'm going to have x minus 3x is negative 2x minus 6 over x plus 2 is greater than or equal to 0. And then this is what I'm going to be using. Okay, let's get roots. That's numerator equal to 0. Negative 2x equals 6. X equals negative 3. All right, and let's get our restrictions. That's denominator equal to 0, so x equals negative 2. Well, not bad because there's only 2 values. All right, so my number line should be a little bit easier. I've got negative 3 and then negative 2. Now I just need to make up some numbers at those intervals. So let's do negative 10 here. Let's do negative 2.5 there, and let's do 0. Okay, so again, the process here, I'm going to plug that into x here and here to figure out if the fraction is going to be positive or negative. So I have a fraction. I plug a negative 10 into the denominator. Negative 10 plus 2 is negative 8, so the bottom of the fraction is negative. Negative 10 up top, a little confusing. Negative 10 there is going to give me a positive 20 minus 6, so that's positive. Look at your fraction. You have a positive divided by a negative. Sorry, it's a little messy, but positive divided by a negative there. Overall is going to be negative. Negative 2.5. Again, it seems very intimidating, but down here it's pretty easy to see, right? Negative 2.5 plus 2 is still going to be negative. All right, that's not hard. Put a negative 2.5 up top here. Well, negative 2.5 times a negative 2 is a positive 5 minus 6 is negative, so the top is negative. And now overall, negative divided by negative is positive. Then I'm going to plug in 0. Well, 0 is awesome to work with. That goes away, so I have negative 6 over 2, which is negative. I don't even need to write that down. Now let's interpret the inequality. I want the positive pieces. I've got closed circle, except at your restriction. So your restriction is open circle. The roots, there's only one of them, the roots would be closed circle because of the or equal to. So that's closed. And greater than or 0, we said we want the positive, which is just that right there. So I have negative 3 is less than or equal to x is less than negative 2. Okay, so once again, I want you to put this in a y1 and take a look at the graph. All right, I'll sketch it here. All right, so I've got a negative 3 and a negative 2. And the negative 2 is your asymptote. And your root is the negative 3. So the graph kind of does this. And then kind of comes up through like this. So once again, if it says greater than, we have to figure out where it is in relation to the x-axis. So this is above or on x-axis. All right, well, above or on x-axis can be that piece and nothing else, right? All the other pieces. This is below, that's below. So I only want this piece. All right, so close circle here and all of this. Probably should use a different color. So again, remember, this is an asymptote. It'll never get here. It'll never get to -2. So that's why it kind of makes sense that this would actually be my interval. -3 to 2, and 2's got to be an open circle, which exactly matches what we got up there. Okay, our last one. Once again, subtract the 4 over. So I have x over x minus 6 minus 4 is less than 0. The common denominator is going to be x minus 6. So I need to multiply by x minus 6 over x minus 6. So that leaves me x over x minus 6 minus 4x minus 24 all over x minus 6 is less than 0. And again, here's that situation. We have a negative. We have to distribute it. All right, so now I need to combine my like terms. That's going to give me x minus 4x is -3x plus 24 over x minus 6. All that's less than 0. This is the fraction we're going to be working with the rest of the way. Let's get our roots. Numerator equal to 0, -3x plus 24 equals 0. Very quickly, you subtract 24 and divide by -3. I got 8. My restrictions. Denominator equal to 0, x equals 6. So the function does not exist when x equals 6. Let's create our plus minus line. Using 6 and 8. And I've got to do plus minus. Right? I have to take numbers in these intervals right here. So let me pick 0. I can pick 0 over here. I can pick 7 right there. And I can pick 10 right there. Plugging in 0 to this, well, those just go away. So you've got -24 divided by -6. That's going to be negative. All right, I don't even have to worry about that. This is going to be negative. If I plug in a 7, all right, let's see what that does to my fraction. Plug in a 7. 7 minus 6 is positive, so the bottom is positive. Put that up top, you get -21 plus 24. That's also positive. So overall, that piece is positive. Plug in a 10. That's going to be positive. -30 plus 24. That's going to be negative. So I have a negative over a positive. Overall, that's going to be negative. This says less than 0. So I want the negative pieces. Everything's going to have an open circle. So that's going to be easy. Open circle, open circle. I want the negative pieces. This solution is going to be x is less than 6 or x is greater than 8. Done. I don't have a ton of room to show you the graph, but it's going to look similar to the one up above. Actually, I'm going to skip the graph for this one. I don't want to try and squeeze it in there and clutter up these notes. So as usual, guys, if you have any questions, don't hesitate to reach out. You've got more than enough information now to do homework 5, and we'll see you guys in class.